Good morning. I'm Kenji Mase from the Informatics Graduate School of Informatics. My laboratory is called the Computer Mediated Communications Lab. We think that the computer is a media for communication, a media between the human to computer, or the human to machine, or human to human. Today, I'm going to talk about e-coaching, data-driven skill coaching, but not directly go into some skills for performance in sports or the manufacturing, but more the basic technology. And you have handouts of my slides, but I'm going to change the order of the talk today. This is a talk summary. The first, I introduce myself and talk a little bit about ubiquitous and wearable computing. In English, I became lower voice. This week I have 5 lectures, so I'm gonna get tired. Okay, and I'm going to talk about some eye tracking related technologies, and then if I have time, I'm going to show introduce the CREST project, which is the Japan Science and Technology Agency's project. I became the research supervisor last year and conducting the project in the most advanced of Japan. So let me introduce myself. I graduated Nagoya University as a master student, and then entered the Nippon Telephone laboratories in Kanagawa Prefecture near Tokyo or Yokohama. And I have a chance to stay at MIT Media Lab for 1 year under the supervision of Professor Pentran, Alex Pentran, who is at that time expert in the computer vision and the human-machine interaction. And today he is the very famous for the social computing. And then return from to the NTT again, and then I moved to ATR, Advanced Telecommunications Research Lab in Kyoto. This is a very unique research laboratory in Japan, because this is the private company, and it is the tackling the basic research. So its income is from, at that time, at my time, from the government, and today they are purchasing, tracking the research funding money. Then I came back to Nagoya University as a professor in 2002. So after at the Nagoya University, I've been moving around from the Information Technology Center, like Supercomputing Center, and the Graduate School of Information Science, and last year it changed the name and the structure to the Graduate School of Informatics. I have been working on the perceptual user interface. Perceptual user interface means that the computer, it tried to give a computer those perceptions in the visual, auditory, and other tactile and things. Mostly that I have a background of the image processing, so that I use the computer vision technology to be used at the human-machine interaction, like the camera, TV camera watching my face, direction, and the movement to know that my interest, and also that looking at the facial expression by using the optical flow, that algorithm that extracted the faint movement on the smooth facial skin, facial tissue. Using the psychological theory that is called and the study of the facial action coding system that help us to code facial action in the action units combinations. And then also we did the gesture recognition using the hand gestures as a remote pointer to the slide on the screen. And this is like some recent Kinect, Microsoft Kinect gesture pointing device. Oops. So that was my the background, and it is related to the evolution of the computer interface. The earlier age of the computer was using a mainframe, the keyboard and the huge printer as an interface. And then when the desktop PC came to the era. And today it is like watches and wearable eyeglasses. And before that, there was and today also the smartphones. And this shows the trend, the distance of the computers to the human, or ourselves, are getting closer. From in the room environment, and maybe 50 to 1 meter distance, and closer, and almost in the pocket, and on your face, on your wrist, on your body. Maybe in the future, and also that there's already some some device that is inside your body, that you are getting closer to those computers. So and also that one different trend is around here. Your interface is like a robot or agent, or the very human-like the Android as your partner. So the computer is getting closer in terms of the distance, and also that getting closer in terms of the identity or personality as your friend or kind. So and also that computing your use time of those computers per day is longer and longer. I don't know how much time you are spending the time with playing with smartphone, but that is the evolution. And so I after the desktop interaction, like perceptual interface, I I have been working on this trend, like wearable computing and also the ubiquitous computing. So at ATR in 2000 actually 2002, after that I came to Japan, to Nagoya. We developed those kind of wearable computing that has the video camera and wearable microphones that can record what you see and what you watch and what you hear in the various interactions. And then the similar device is also attached to those posters or the ceiling or walls, and to capture the holistic events that you stays. And also that we exploit such a device that emit identification code to those wearable device, so that this code shows the identity of the things or the names of the wearer. For example, here this ID tag is attached on the panel of the presentation poster, and then and also the 120 is the number, ID number of this tag. Then by using the image processing of this ID decoding, we can tell that here the 120 things exist, and that is connected that this is a panel about robot. And also the device is worn by the people, and the wearer's ID is identified by number 24, and the 24 is connected to the name Mr. Koide as an exhibitor. So by using those visual camera and the ID tag reading camera, we can record visual information and also that things in the space simultaneously, and also that those tags gives the information about spatial positions. So by using those device by the people in this space and also that in the environment, we can capture the events, what is happening, what kind of interactions exist in the space. So this is those are my old backgrounds, and after I became Nagoya, again we have talked the things, and I show you later. So I am very much interested in the wearables because it is personal, and because it is very much close to your body, and as you wear the device can capture all the time as you wish. Those PC is the only used when I approach to the device, and the smartphone is a kind of wearable in between those wearable and those PC. As you, if you like, you can bring those smartphone. This is a new one. I want to show you. But as I just showed you, that I was putting the device in my bag, so the distance was closer. Those device doesn't know my activity for last 20 minutes. But if I wear those device as a watch or some wearing device like clothing, it can move along with my activities all the day as if I like, wish, or even during the sleeping time that it knows what I'm doing. So it is very personal and private, and it can take a log of myself. And the wearable is always referred as the device always on. So it also has some sensing and displaying the clues. And if you like that those sensors set on all time, then and that can record automatically. And then that it can record your experience without disturbing your main activity. My main activity here is giving a lecture. But if that kind of device, a TV camera or those wearing device can record my activities, I don't need to care about how I am being shot. Or that if I go to some sports event and I use the camera, the video camera, to capture those sports events. But while you taking the video or the cameras, that you need to concentrate how to manipulate those devices. You are far from the sports event itself. So the wearable device which is all the time the recording and the experiencing, recording the experience, it helps your the experience recording, and after a while that you can enjoy. You can enjoy the event itself at the time, and also that later you can refrain those experiences. And that is a very close information device. And also that wearable is referred as the two hands-free device. Unfortunately, those mobile phone is not allow you to use both hands, and one hand has to need to manipulate. And for the good example is some maintenance of the big system like aircraft. The Boeing aircraft has introduced those wearable devices to help the maintenance engineers to how to say, the airplane diagnostics, the procedures on your display, and also some overlay of the diagram, how to touch the circuit or the device. So, two hands free is a very important thing, and also those wearable devices provides you rich data in the first person capturing. So this is very interesting. And also that ubiquitous and wearables, friends. Ubiquitous means ubiquitous is that from the Latin word, language. It means that exists everywhere. So it is. It gives some group log and wider view, and again that it can be also always on. Unfortunately, in this room, that there is no. Fortunately or unfortunately, no wearable ubiquitous device. Only some the microphone audio capturing device is attached, and also that room temperature sensors help us to enjoy the comfortable climate in the room. And again, that it can. It is always on for sensing and automatic recording experience. But different to the wearable device, it gives a third-person view and social data. And it is the device for the interaction log between object and people. And this is my the picture of my work is to introduce some future intelligent information system that supports the activity in the real world. In order to that you need to sense the activities and help the activity on the internet. Those intelligent information system helps your activity and searching and meeting and everything. In order to those information system be intelligent and more useful or usable, we need to we need to know those users' interest and also the users' way of interaction, interacting to other people, or way of interacting to the system, and their interest or attention through those the intelligence interactions. Then my idea is to use to capture that activity log as in my sense it's a live log. You can tell that is a small big data to IoT interaction record, but the wording can be different. But anyway, this is activity live log. In each device or service, we can record the micro life log, and then we can make a huge corpus for the system or some independent users. Then the idea is to produce the humans activity dictionary in from those life log. Then those dictionary is used for the intelligent information system as a reference. That will give more the intimate or the accurate or usable interactions. That is my future device. So those data circulation appears that is close to this leading program, I think. So my recent the interest about research is e-coaching. Coaching is I mentioned later, but by using those activity logs, we can help those people by the help of IT technology. various way, like simulate, analysis, visualize, case study, event capture, and some assistance, or the future, the guidebook or modeling. Okay. So how much time I do I have? 15?
11:10.
Huh?
11:10.
11:10. Okay. Okay. The e-coaching is the coach or the subject interactions. They have some communications, and they use some device to help the coaching, skill assessment, scientific analysis, and visualization, and also those coach need to motivate themselves or help self-assessment by those feedbacks. And also at the coach side, the development of the teaching theory and the curriculum is also necessary, and we think that the technology can help. And also as I mentioned, that those devices like wearable or ubiquitous system can help sharing the experience of those skills or the teaching and the mentoring in performance and the viewpoint and body sensations. And when the large database is collected for the various people, some big data analysis for the visualization or checking for the trend is possible. And also today some biological devices introduced to find emotive or motivative, the sensing is help for those people. The origin of coaching is this, you know or not. This is called coach, cattle. And the coach is brings clients to the destination presently. And then today coaching came from this idea that the sportsmen or men and women, some businessmen be reached to some destination in present way. That is a coach. So the coaching is possible by communicating with clients, and it needs some mutual understanding and recall the motivation or the data, and the technology helps self-motivation and targeting and awareness and planning and follow-up. That is, I think, possible. The body of knowledge of training and teaching skill in sports coaching and self-development programs will be possible with the information technology and wearable and ubiquitous devices, I think. So in those coaching, some core things can be listed like this. Those are awareness providing and skill understanding, and the skill transformation from the coaches to the trainee, and sometimes the motivation need to be created, and those information technology and the system or service can assist. And those things many cases the trainee think or the coach have some implicit idea or tacit idea, but we need to those things be more the conscious or formal. That I think that the technology can support those movement. And I want to give an example of such technology. from the eye gaze technology. Eye tracking is a kind of implicit and input and output from you. You watch things. You may have the attention or the interest to the things, but your movement, eye movement, is very much implicit, and that is very interesting device, I think. The modern technology for such device, how to capture that eye gaze is to use those Purkinje image reflection from the IR LED, infrared LED, the targeting the eyeball, and then that beside of the center of pupil, those Purkinje image appears on your eyeball. Then the relative position to the pupil to the Purkinje image gives you the direction of the eye face. This is the actual example of those devices, how the camera is targeting the eye. This is the pupil, and this is a Purkinje image reflection. Then the relative position is captured by image processing, and then the direction of the eyeball can be discerned. The history of the eye tracking is that go back to nearly 70 years ago. You may see those pictures, some people in the room entering from the door, and those lines and dots, the eye position, eye tracking examples. And Alfred Yarbus explained those devices and experimental result in book published in 1967. That his work has been performed in 50s and 60s. These interesting example that is written here, but when the experimenter asks a question to the experimentee, the subject, it changes the way of the watching the picture, and checking the whole room environment, or each person, or the things. And the recent work is used how the people are reading those text on the web. Those red and green pattern is called the heat map of the eye tracking. So red area is given the longer time of the eye track. This is an example of how the men and women watch differently in those pictures in terms of eye tracking. So that kind of the difference between people, or between age and or those target taken. I want to show you some interesting technologies, recent interesting technology about the eye tracking. That Purkinje image method is one today major things, but also we have the search coil method. I show you a video of this device, not this one. the search coil, it
High accuracy eye tracking could enable new kinds of interactions and studies of how humans respond to virtual reality. Traditional optical eye trackers are difficult to integrate into the optics of a head-mounted display. VR-compatible eye trackers are typically only half a degree accurate with a low data rate. Today, the gold standard for eye tracking is magnetic.
you see the contact lens here
search coils.
with the lead.
Here wear the contact containing a wire loop.
In the contact lens, you have the coil,
Generated by large coils.
and the search coil means that the interaction between those the outer side coil and the contact lens coil magnetic resonance is captured.
The high accuracy scleral
So those are the huge coil to find the position, orientation of the contact lens.
without the need to
Then the action of the contact lens is used as a eye tracking. So this is the today's or future technology. Even as you saw, that contact lens needs the power intake. But in the future, that will be the
allows us to view the HMD screen as if we were
self-powered,
with
I
our
hope.
We automate the collection of over 30,000 data points, which takes approximately 8 hours. This allows us to
This is the slides from the wearable computing in 2 years ago, I think. And I want to show you another example using the gaze. This is a gaze touch interface by those people, Prefer and Alexander Kohn and Professor Gillarsen at Lancaster University, England. And that is, again, very interesting work. So it uses gaze and hand gesture simultaneously. So your eye gaze pick up some slides on the gallery, and in normal the graphical user interface, you have to place your hands onto the target object. But by using the eye gaze as the hint for your interest, your hand position can be arbitrary. So any kinds of manipulation on the distance to the real target that can be connected by the help of the eye gaze. This is cool interface, I think. You don't need to place your hands on the place that you want to enlarge the scale. You just watch, give the gaze to the object. Okay, I'm running my time. Oops. So I have a few more the slides, but I skipped. And In our laboratory, we are using those eye gaze to find how the soccer coach is watching a game in their training, in their coaching session. Those coaches, expert coach doesn't look at the ball, even if it locates to close to the goal, but rather they are watching the player in the opposite action. If they are in the targeting the goal, there are some defense player being watched or something like that. So sorry about I put myself introduction so much. If you are interested in that Japan Science Technology Research Program, please come to me anytime. Okay, I stop my talk here.